Okay, good day everyone. So this is our last two topic for the physical factors of the environment and its sampling methods. So we only have two topics left. We have water quality and soil quality. So let me present to you water quality. So I just have to turn off my video so I won't be conscious enough again to explain. Okay, so now let's talk about water quality. Okay, for a while, I have to show my pointer again. Okay, so water is a common chemical substance that is essential for the survival of all known forms of life. And water quality reflects the composition of water as affected by natural causes of man's cultural activities. And we define water quality, in different ways. We perceive it differently in every people. So, for example, a public health official. For example, they are more concerned of the bacterial and viral safety of water used in drinking and bathing. For others, no, for example, the fishermen, they are concerned that the water quality of water be clean enough to provide the best habitat for fish. Another is for aquatic scientists, no, they are concerned with health of aquatic habitats, including fish, plankton, and other plants and organisms. So definitely water quality has different meanings to everyone. No, not everyone knows what water quality means. So for us, no, we know water quality a bit, but as we go along or as we move with to higher what do you call this, higher subjects or courses, no, we begin to know how water quality affects the environment. So let's now have pollution. So when we talk about water quality, it also involves pollution. And when there is pollution, of course, it's the intervention of humans, to be specific. So what is pollution? It changes in the quality of environment due to natural causes. No, so definitely when we talk about pollution, guys, it refers to a change in the physical, chemical, radiological, or biological quality of resource, either air, land, or water. So basically, that is the general definition of pollution. So we're not just talking about pollution only in water, but pollution as a whole. So definitely pollution is caused by man or due to man's activities. That is, of course, injurious to existing, intended, or potential uses of the resource. So also it changes the quality of environment due to natural causes. So for example, we cannot just blame human activities for pollution, but there are also natural way, of how this pollution, is existing. So example, volcanic eruptions, no, kani sila. The deposition of fly ash from the natural forest fires. Of course, this is also one of the natural phenomena we have erosion, of course, and weathering of rocks. Those affects pollution in many ways. So water quality and pollution are determined and measured by comparing physical, chemical, biological, microbiological, and radiological quantities and parameters to set off standards and criteria. So basically, our water resources is composed of 97% salt water, which of course consists of oceans and seas. 2.4% of those are the glaciers and the polar ice caps, and 0.6% are the other land surface, which includes river, lakes, and ponds. So ina nakagamay ang atuang ko ano. And if you can see our overall they call this map or the globe itself, no, we are made up of water. 3/4 of um, the 3/4 of the volume or the mass of the earth is composed of water. So groundwater, all water that saturates the tiny spaces between alluvial material, examples sands, gravel, silt, clay, or the crevices or crevices or fractures in rocks. This includes the aeration zone, aquifers, saturation zones, capillary water, and water-bearing rocks. So a very small amount of Earth's water is contained with water towers, biological bodies, manufactured products, and food stores. So the water quality in the Philippines is here in the Philippines, our water resources include inland fresh lands or fresh water, lakes, and even coastal and oceanic waters. So kaning mga inland water, fresh water nato includes rivers, lakes, and even groundwater. So water quality in the Philippines, water quality protection and operation and maintenance of sanitation facilities are collaborative undertaking of the Department of Environment and Natural Resources, or the DENR, through the Environmental Management Bureau, or the EMB, and even the Department of Health for the safety of our potable drinking water, and of course the Department of Works and Sewerage systems for the connection of our water in different parts here, not only in Mindanao, but all over the Philippines. So the problem here is that there are too many policies and laws about water quality that some of them are not implemented. So napud ani uban na wala pud gi-monitor. And then some agencies have unclear and overlapping mandates. So kung kani si nagmandar si DNR ngayon anin ana, siguro po si DOH na po siya lahi po ka mandate ngayon anin ana safe lang, no? Si DNR dili safe. So usa gid ang ato ang kuan. Usa gid ato ang take ana. So now the DENR or the DNR Administrative Order number 34 series of 1990, in which they classify or this certain type of water in which they clearly classify it with different classes. So they define it, what's the beneficial use of these classes under this classification. So for example, we have class AA, class A, class B, so definitely what is really the aim of the Philippine government with this classification? So ang ilahang gusto gid nga ma-attain ani is or i-aim ani is to maintain the quality of the surface waters according to their best beneficial use. So this is of course embodied the DNR Administrative Order number 34 series of 1990, which classifies bodies of water according to the degree of protection required. So as you can see, class AA, now this class is intended primarily for waters having watersheds which are uninhabited and otherwise protected, and which require only approved disinfection in order to meet the national standards for drinking water of the Philippines. So basically, the Class AA and even the Class SA will have that, no? Have the most stringent water quality for fresh water or fresh surface waters and marine or coastal waters. So kani sila mo ni sila ang mga gikanan sa ato ang tubig, kay gikan man ni sila sa watershed, no? And they are protected. So dili basta-basta nga mag-ato ka dito. These watersheds, no, are being protected by the IPs or the indigenous people. So sila ang protector ana. And then we also have the Class A, which is for fresh surface waters. These are for drinking. Na this undergone complete treatment. So niagi na siya coagulation, sedimentation, filtration, and even disinfection in order to meet the National Standards for Drinking Water, or NSDW. The Class B is what we call the recreational water Class 1. So this is for primary contact recreation such as bathing, swimming, skin diving. So more on tourism ni siya. So beach resort can also be included in this class. So kaning yes, kay bathing man and swimming and even skin diving. So another is, of course, Class C, which is for fishery water for propagation and growth of fish and other aquatic resources. So maybe na ay part dani nung estuary baka ni, so murag ilahang gina-culture ang mga freshwater na not really freshwater, but it's an estuarine mga organisms such as kanang mga shrimps, no, bangos, nga ang estuary is what we mean by where fresh water and the sea or the ocean or the sea water no meets. So it's a combination of parat-parat o naabot siya kanang kuan lang pure water. So dili ka siya parat gyud kaayo compared with dagat gyud na tubig, no. So under this class, no, is the recreational water Class 2 kung na ay gabot diha to harvest shells or even fish, no, fishes, no. So those are under Class C classification. So for Class D, this is for agricultural, irrigation, livestock watering. So basically, mao ni siya ang katong sa mga agricultural land areas na kung mag-irrigation sila, then muna siyang gine-define na to, gina-classify na siya as Class D. And even kani mga industrial water supply, no, Class 2 na pangkuling sa ilahang mga facilities, this is also dili na siya pwede mainom, of course. So gina-classify na to siya as Class D. And even Class SA, no, kani siya. Same with Class AA, in which suitable na siya for a lot of reserves and watersheds. So ginaprotektahan gini siya per me. So for Class SB, we have Class SC and of course Class ST. So basically, naa siya mga effluent standards. So for example, ang kaning mga Class SB, fishery water Class 1 for milk fish or yes. So kibali tanaw nila kung ang milk manggod is dali ra siya madaot, so it's prone to bacterial or kanang bacteria or microorganisms. So definitely kailangan tanawon ang total coliform if there are if kung magtaas na siya, so meaning bawal siya, so naay mga sanction nga ginabuhat ang DNR if for example naay i-release sa isa ka industry ang ilang wastewater without doing treatment to their effluent, no? So they have to follow effluent standards before they release it to the river, no, or a nearby water. So Class SC has no standards, and even Class ST. So those are examples or are the classification of the Dow 34. series of 1919 on the water quality. Actually, the Dow 34 has now been revised. I think, I'm not sure, but try to search on Dow 34 series of 2016 or 2017. So, I think mauna na siya ang bago. So, another na for the quality of Philippine water resources, no, over half of the Philippine rivers that were classified have lower quality and cannot be used for drinking unless treated. So definitely our water, no, compared with other water resources, no, for example, in Australia, they even use their kining tubig gripo para mag ano lang mag what you call this mo inom og tubig. So definitely here we cannot, so siguro pwede sa uban labi na katong mga naanad na sa ilahang mga tiya, no, but for others, no, there might be some changes in their activities sa ilang tummy. It's because natin ginatawag ng mga amoeba that when they multiply, of course, this would give an effect to your body, you know, magkalibanga ka, magsukaha ka, so ano, siya sa tubig, can be present in water and even in the food. So the coastal waters are densely populated, thus causing water pollution. Of course, coastal areas nowadays, no, has been dominated with residential areas, labi na katong mga nagpuyo lang, na nagbarong-barong lang sa kilid sa coastal areas, no, like you can see that in Opol. It's very evident, very evident, no, na doon na sila sa coastal areas. So some of their waste or even kanang mga kaliguan nila dana na lang mo padulong sa coastal nga area. So mao na siya nga it would cause water pollution. And Philippines' main source of water is, of course, rainfall. So definitely we receive thousands annually, and we are also expecting a lot of typhoons every November to December. No, so dana na atong mga tig-ulan kay mga June. So pag mohapit na mo abot ang December, usually we experience a lot of typhoons. So mo na siya, no. And then the surface and groundwater quality shows the problem is getting severe in urban and coastal areas. So definitely in urban areas, no, unlike rural areas in which mga provinces, dili kayo dito kayo polluted, but here in the city, since there are a lot of establishments, a lot of people, overpopulated with people, so definitely we generate more waste, no, and we generate more pollution in that way. So kana siya, no, clean water should be the priority, because 58% of the groundwater wells that were sampled were contaminated with coliform. So that is one of the findings of Philippine Water Resources nato nga taas kay coliform. So it could definitely caused by the microorganisms. So kung once ato ni siyang ma-intake, no, there is a big impact sa ato ang body. So definitely magkalibanga to, it would lead to dehydration, and dehydration could lead to death. So that's it. Water contamination contributes to low water quality, resulting in water pollution. So this is the result of urbanization. So as the people flock into the metropolis and build homes, water quality problems arise. It's because in provinces, in rural areas, there are less, they say that there are less opportunities given to them. So that's why they move to higher kaning mga metropolitans or metropolis And then dito sila manabaho kay mas dako daw og sweldo. And the effect would be water quality problems. So basically, no, when this water quality, no, when the water quality parameters exceeds the Dow 34 standard series of 1990, or even the newest or the latest, the series of 2016 or 17. So by kung naalagay mag-exceed ang nag-isa or more standards sa criteria nga kuan, it implies that there is an injury to the water quality. So definitely kailangan din siya rehabilitate. So the quality or the quantity of potential pollutants can be discharged into the environment receiving water body. So it is now called as waste assimilative capacity. So kung for example, ma-discharge na siya sa environment, tapos ma-receive siya sa water body, either in the atmosphere or land, muna siyang kasabot nato sa WAC, Waste Assimilative Capacity, or WAC. So kung once nga kuan na ni siya, ma-release na, masagol siya either atmosphere or land or even water body, it's now what we call waste assimilative capacity. Okay, so now let's move on to water quality measures. So there are a lot of methods of measuring water quality. So basically, the commonly used methods for measuring the quality of water and the pollution includes the physical, chemical, and biological parameters. And these are the following. No, that includes the physical, chemical, and biological parameters. So the detailed description of the methods of determining these parameters is outside the scope of this course. So definitely this can be found in the American Public Health publication in the reference index. So kamu na bahala kay we had this in our ecology, nag-introduction ta on specific water quality measurement, or how we measure it or how we analyze it. But as for the individual detailed description or the methods, so I hope na you'll do your part on this methods for measuring water quality. So okay, let's now move on to environmental water quality parameters. So for the physical, we consider color, odor, temperature, solids, turbidity, oil content, and grease content on the physical properties of water quality. For the chemical properties, we have the pH, the conductivity, dissolved oxygen, nitrate, orthophosphate, chemical oxygen demand, biological oxygen demand, and pesticides. And for the biological properties, bacteriological parameters includes coliforms, fecal coliforms, specific pathogens, and even viruses. So let's now have first the biochemical oxygen demand. So biological oxygen demand or biochemical oxygen demand is a measure of how much oxygen is used by microorganisms in the aerobic oxidation of or breakdown of organic matter in the streams. So basically, ang biochemical oxygen demand is determining the dead organic matter in stream decays. So muni sila ang mga bacteria carrying out nga kung mag-decay na ning mga material, mag-require silang oxygen. So they get this oxygen coming from the decaying materials so that they can multiply sa ilalom sa tubig. So that's why naatay ginatawag nga biochemical oxygen demand. So usually the higher amount of organic material found in the stream, so the more oxygen nga magamit, the more put ang aerobic oxidation. So meaning, pag naay kaning excess amount of oxygen inside or underwater, ilahat tong gamiton katong mga microorganisms para multiply sila or mudaghan sila ana nga tubig. So the more polluted the water is, no, mas magkadako ang ilahang demand sa oxygen. Mas taas ang ilahang makuha ang oxygen. It's because the oxygen is coming from the decaying materials, no, underwater. So this depletes the amount of dissolved oxygen available to other aquatic life. So now it has become an issue or concern on the biochemical oxygen demand because as the material decays, no, these organisms use the oxygen underwater in order for them to multiply, causing it, no, for the oxygen to be less underwater. So unsay mahitabo ani? Ang mga isda karon, mga matay sila because they compete oxygen towards the microorganisms. Kay mangita sila og oxygen for them to survive. And since nga gideplete naman ng oxygen or gigamit na for aerobic oxidation, gigamit na siya sa microorganisms, less na lang ang oxygen nga magamit sa isda. That's why naatay mahitabo nga mga fish kills because of the oxygen demand pod, no? So that's it, no? This measurement is, of course, obtained over a period of 5 days, and it is expressed in mg per liter or milligram per liter. So basically, the standard for BOD in water is not more than 5 milligram per liter. So more than that, no, naa siya'y kuan kining effect. So there might be a lot of pollution underwater, and it should be rehabilitated. It should undergo rehabilitation, I mean. So as you can see, if we base DO and BOD, there is, of course, a indirect na relationship. Kay kung for example, mas greater ang DO, supposedly indirect sila. So dapat mas taas ang DO kung ang BOD gamay. So satisfactory siya kung lesser ang BOD. Satisfactory pud ang DO kung greater than 5 yang BOD. So mo na siya, no? Unsatisfactory siya kung mutaas ang DO, no? Tapos unsatisfactory pod ang BOD kung mubo siya. So dapat ang iyang relationship with the DO is, of course, inverse or indirect nga relationship. No, inverse sila. They are inversely proportional. So kung mutaas ang BOD, dapat mubo ang DO. Or kung mutaas ang DO, mubo ang BOD. So that's it. No, it's either other way around. No? So kamo depende na sa results sa inyong test. So that's it. So okay, for method of measuring BOD, no, this is how we measure BOD, but definitely this is not very detailed because it undergoes a lot of processes in which now you need to prepare a lot of chemicals, dilution, tapos naapamoy kining solutions na i-add sa BOD before you can perform this method. So basically, ang iyang general lang is you place a water sample in a fully airtight 250 to 300 ml capacity incubation bottles with round glass stopper. Then the bottle will now be incubated under specified conditions for a specified time, which is 5 days. BOD will take 5 days for it to know the results. No? Okay. Ang initial BOD will be minus or subtracted to the final BOD. So after 5 days, that will be the final BOD. So that will be discussed in your maybe in your higher na nga kuan katong I think water pollution maybe nga lab. So dani dili na kita mag-discuss more on how method is done, or basically dili na ta discuss on the kuan nga side kanang very detailed. So the solved oxygen is measured initially and after incubation, and the BOD is computed from the difference between initial and final BO. So that's it. So kining samples for BOD's analysis no may degrade significantly during storage between collection and analysis, resulting to low BOD value. So definitely when you get a BOD sample, make sure na kining tightly capped, so dapat wala siya bubbles kung magkuha ka. The bottle should be immersed and then it will be capped under water. So dapat pag tangtangi mo i-upside down ni ay pagkuha nimo siya sa tubig, i-upside down nimo kung naay mo saka nga bubbles, it means you're doing it wrong. So you need to get another sample, water sample na po. So basically no, when you get samples, BOD manggod degrades really fast. So within 4 hours, 2 to 4 hours, madaot na siya. So there will be an alteration of result pag dili siya madala sa lab diretso, dili siya diretso ma-process. So what you will do is that you need to bring with you your ice bucket. Then you have to fill it with a lot of ice. So the measurement for BOD sample should reach -4 degrees. So dana lang in a way nga dili siya dali madaot ang inyong sample. Kay kung madugay na siya, mas paspas man ang pag-multiply sa microorganisms. So that's why mag-alter na dahil ng inyong tests for BOD. So ang makita na noon sa BOD is, taas kaayo ang BOD, so polluted kayong water, pero human error naman di ay. It's because ang mali ang inyong pag-store sa inyong water sample na BOD. So it should be initiated, no? Analysis should be initiated within 2 hours of collection. Then, po dayon, within 6 hours of collection. 2 hours lang na siya for analysis, and it should go within 6 hours for collection. So within 6 hours, you need to throw the water na katungod kay dili na siya reliable. So as BOD in streams and rivers, water increases, DO decreases. So dana lang kita pamintinan nyo, I think nga they have an inverse relationship. BOD increases, DO decreases. So that's for BOD. So now let's move on to total nitrogen and phosphorus. So before that, no, I have to introduce these terms because basin mawala mo no nga nawala na ta nitrogen na magututong istoryaan, but definitely there are different kuan na siya composition kung once nga na siya isagol. So there are 3 important forms of nitrogen. We have the nitrate, nitrite, and ammonia. So usually when we do analysis, no, we usually use the total nitrogen kung magpa-analyze mo sa kaning fast lab or somewhere nga mga na-analysis no nga. total nitrogen siya. It's because it composed of nitrate, nitrite, and ammonia. So what is nitrate or NO3? So it is the most soluble form and does not bind to soil particles to form insoluble compounds with other elements in the soil. So it can easily enter surface water bodies through runoff or percolate deep into the ground and contaminate groundwater. So this means that ang nitrates, guys, can easily enter the surface water bodies through runoff. No? So kani siya, it transports large amounts of nitrate to surface waters, and it can also be rapidly taken up by the aquatic plants and can lead to eutrophication in the same way phosphorus can. So nani sila kaning mga nitrates and phosphates are somehow the same kung sa iyang effect. So usually this nitrate, no, it's a nutrient growth to other plants. And if you can imagine, no, kanang river bitaw nga green bitaw, especially kanang during summer, it is caused by nitrates and phosphates. That's why there is what we call algal bloom or kana siya or eutrophication, in which na gina-cover niya ang kining water with kining mga green plants. These are algae na pag-cover niya sa water, di na makapenetrate ang sunlight, so it would also cause fish kills. So mao na siya, no. Furthermore, no, kaning mga nitrate is much less toxic than ammonia or nitrite. It's because yes, kuan siya, it can still be toxic to some forms of aquatic life, but I'm not saying it's very safe. No, napod na siya effects sa other aquatic life. Kaning ammonia manggid is the ionic form of ammonia. And unlike nitrate, it does not bind to soil particles. So basically, medyo stable siya. It is more stable form of nitrogen in soil. So dili man siya mopikit sa particles, kundi siya gabind sa soil particles. So, however, concentrations of ammonium in the soil are generally quite low because it is quickly converted to nitrate. So, kaning ammonium, that's why ato ang ginatest mong good for soil quality is total nitrogen. It's because kaning ammonium dali ra siya mawala. So, ma-convert na din siya into nitrate. So, that's why total ammonium ato ang gina-test. So, an exception is when a large volume of ammonium fertilizer or manure is applied to a field, no, just before an intense precipitation event. So, kung kani siya, kung taas kayo ang volume, or yes, large volume of fertilizer or manure is applied sa field, then it can also have a great impact. So this can be washed concentratedly. So sa surface water bodies. So madala niya siya sa surface water, no. And this ammonium will then be converted to ammonia, which is toxic to fish and other aquatic life. So basically, dili siya matawag na safe yun ang kaning part, no, kaning what you call that important forms of nitrogen. So another is nitrite or NO2. So it is the intermediate form of nitrogen between ammonium and nitrate. And because the conversion process is rapid, it does not accumulate in the soil. So same with nitrate, no? Na they cannot easily bind in soil particles. So this can not also be accumulated in the soil. So, ang nitrite does not bind to soil particles and easily carried into surface water bodies by runoff. So, ang iyahalang effect ani is pwede siya ma-wash out and can also be present to the nearby bodies of water kay because kung mag-run off na siya, niya mo ato siya sa kuan kaning duol nga mga bodies of water, it can contaminate the water itself. So, though through the use of nitrogen fertilizers, the manure application for crop production, the agricultural sector is a large contributor of non-point source nitrate to surface and groundwaters. So basically, agricultural sector has the large contributor of non-point source. It's because no, na ay presence of nitrogen in the manure which can be applied to crops to try to reduce amount being carried by runoff. So basically, when kung manure are being introduced in agricultural sectors, then this could kuan ano unsay tawag ani na I mean kining what I mean is that when you put nitrogen fertilizers, no, it could affect the agricultural, I mean, it could affect the water bodies, nearby water bodies, because it will, the runoff will, of course, flow to the nearby water bodies of water. Then it can also pollute groundwater in which nga mag-leach siya, percolate siya, tapos wato din siya sa ilalong underground. So, pwede siya nga mo-flow siya sa tubig nearby kung na ay mga well dara or kanang mga pumps. So, ang may tabo sa iya is makapollute gid siya og kanang mga nearby potable water, drinking water, such as pumps, mga pumps. So, another is that kining mga intensive livestock operations, no, they produce also large amounts of manure and it is used as fertilizer. So, supposedly the correct application for nitrogen requirements results in excess phosphorus being applied to crops. So if there is a presence of nitrogen, there is also a presence of phosphorus. So they always go together. No, kani mo man sila ang kuan kaning culprit for what do you call this, algal blooms or eutrophication. So unlike commercial fertilizers, guys, kaning mga nitrogen and phosphorus concentration can be matched to crop requirements. So basically, kung mga commercial fertilizers lang ni siya, there is a ratio that should be done. So kung for example, in nitrate and phosphorus, dapat fixed yun siya. So dili siya nga parehas sa kaning manure yun nga diretsyo mo siya i-apply, there is no ratio. Tungod kay mura man siyang gigamit ang iyang tae mismo. So dili na nimo siya ma-ratio nga pila ka maybe 16-16 or 12-12, maybe ana. So basically, concentrated na kaayo ang naa sa manure. But for commercial, no, they apply ratio. So, of course, manure applications can lead to a buildup of phosphorus in the soil and increase phosphorus inputs to surface waters through runoff. So, as a result, na efforts to apply phosphorus concentration that are more closely matched crop requirements to minimize soil erosion and runoff are very important for avoiding phosphorus contamination in water bodies. So, mao na siya, no? Kailangan ratio lang, dili siya concentrated. So now let's move on to ammonia. So it is a form of nitrogen produced by the decomposition of organic material. And if found in water, ammonia can be highly toxic to aquatic organisms. And of course, it can be discharged by municipal and industrial wastewater effluents. So in most well-oxygenated waters, no, ammonia is converted quickly to non-toxic nitrate, which is a nutrient necessary for plant growth. So basically, dili ni siya, usahay na ni siya, rare cases or sometimes ammonia can be present in the water, but in high amounts lang, kaya ra siya makita. Pero kung gamay ra siya, ammonia will then quickly be converted into non-toxic nitrate. So, mo transform na siya into another substance that can be used or that can, yes, that can be used by other organisms such as the algae, no? Nga mo grow sila, mas modaghan sila because of the nutrient growth given or released by nitrate. So ammonia gas can be lost when manure or ammonia-based fertilizers are applied to field under warm, dry conditions and are not mixed into the soil. So basically, dali ra siya ang vapor niya no dali ra mawala. Kay tungod kay kung ma-apply na siya, kung labi na kainit mo na siya og mag-evaporate, no? Init siya, dry pa gid kay ang condition and wala pa gid siya na mix sa soil. So in that case, ammonia is converted to another substance. So now let's move on to total phosphorus. So total phosphorus is an essential nutrient for plants and animals. It is naturally limited in most freshwater systems because it is not as abundant as carbon and nitrogen. So introducing a small amount aning phosphorus into a waterway can have an adverse effect to the water, nearby water. And then kaning mga adverse effects include algal blooms, accelerated plant growth, and low dissolved oxygen from the decomposition of additional vegetation. So katong mga green no sa tubig, mao na sila mga algae or algal blooms na sila. And then some of the plants no which are let's say ganahan ng phosphorus that mo absorb og content nga phosphorus, mas mudako sila because of the phosphorus, total phosphorus present, no? And even it could also low dissolve oxygen in a way na this is they will compete for oxygen sa katong natabunan na nga part nga dili na kayo maglisod na sila, wala na kayo space, maglisod nag-penetrate sa sunlight because it was now covered by the algal blooms. So na siya may mahitabo nga fish kills yapon. So that's it. So phosphorus is a nutrient important for plant growth. That's one of the fact that we need to know. Importante gyapon ang phosphorus. So in most lakes, phosphorus is the limiting nutrient, which means that everything that plants and algae need to grow is available in excess, no, except phosphorus. So kaning sa lakes, no, usually kaning mga lakes are kuan man ni dili man ni siya galihok. So still waters lang ni siya. So basically kuan lang siya. Makita ninyo nga very clear ang mga lakes. But it doesn't mean nga kung clear ang lakes pasabot ana syada ang quality sa tubig. So ang may tabo is that kaning mga lakes no does not have phosphorus. Ang ilaha lang is naa sila available access in terms of sunlight, warmth, water, nitrogen, but except phosphorus. Wala sila presence of phosphorus. So this means that phosphorus has a direct effect on plant and algal growth in lakes. The more phosphorus is available, the more plants and algae there are in the lake. So if you can see, if you've seen a lake, na nakita niyo nga grabe siya ka limpyo, grabe ka kuan crystal clear, but the quality is not habitable. So naay uban ana nga mga plants or even organisms that are not capable of surviving in that kind of water resource ang ato ang lakes. So basically, no, phosphorus originates from a variety of sources, many of which are related to human activities. So a major sources no includes human and animal waste. So basically, it's made up of phosphorus. Even soil erosion no, contains phosphorus, detergents, septic systems, and even runoff from the farmland or fertilized lawns contains phosphorus. So mo na siya asa ginagikan ang phosphorus. So phosphorus is usually measured in two ways in lakes, no? We have the orthophosphate and the total phosphorus. Kaning orthophosphate is a soluble reactive phosphorus in which that it is chemically active dissolved form of phosphorus that is taken up directly by plants. So orthophosphate levels fluctuate daily, and in lakes, there are usually isn't a lot of orthophosphate because it is incorporated into plants quickly. So diretso ra ni siya i-absorb sa plants. So dili kini siya gakakita. And every day, lahi-lahi no or ga-fluctuate ang iyang levels. Kaya magdepende na siya kung na ay presence of plants. So another is total phosphorus. It is a better way to measure phosphorus in lakes because it includes both orthophosphate and the phosphorus in plant and animal fragments suspended in lake water. So basically, total phosphorus, same with total nitrogen, are usually um, tested or analyzed by if you sample water quality or water if you want to know the water quality of that particular lake. So total phosphorus and total nitrogen ang gina-offer nila. So if we can relate that nga let us compare the lake fully mixed during spring and fall and the lake stratified during summer and winter. So, kanino, this is the other way that phosphorus can enter lakes through sediments at the bottom of the lake. Kani mga sediments na bottom sa lake, no? So, usually, kani sila, ginatawag na to ng mga anoxic because in the late summer and late winter, low na ilang oxygen. So, mo na siya pasabot sa anoxic. So, mo na siya no nga ang chemical processes sa sediment or sa water nga interface cause phosphorus to release from the sediments. So this phenomenon is called internal loading because the phosphorus is coming from within the lake or from the sediment. And when the lake mixes again, this increased phosphorus fuel, which fuels algae growth or algal bloom. So muna siya. So if phosphorus inputs are decreased or eliminated, muna siya nga naapod siya effect, which is less plants and algae are available to grow and water quality can improve. So muna siya no. So now let's move on to acidity. Acidity is one of the primary indicators used for evaluating surface water quality and the suitability of various beneficial uses. So most aquatic biota are sensitive to pH variation. If we can define pH, no, it is the basicity or the acidity of measurement of basicity or how basic or how acidic a water can be. So pH is what we call potential hydrogen. And kung ano no, pH can vary in different habitats so, and in different organisms. So there are organisms that are maybe tolerant to high acidity or maybe tolerant to low acidity. So kining ko ano, most aquatic species prefer a pH near neutral. However, they can withstand a pH with a range of about 6 to 8.5. So actually, no, the toxicity of many compounds can also be altered if the pH is changed. So the solubility of many metals no, as well as other compounds is affected by pH, so resulting increased toxicity in the lower pH range. So basically, no kaning uban aning pH, no, there are some metals during leaching, no mag-leach siya, from soils caused by elevated acidity of precipitation, which represents a time bomb and a threat to sustainability of soil resources. So basically, if kaning mga kung ano na ay mag-bleach ang soil metals, naapod siya effect, or siya time bomb, no? And as well as threat sa sustainability sa soil resources. So two sources of pH or acidity change. We have the acid precipitation and the mine acid drainage. For the acid precipitation, it is caused by atmospheric sulfur and nitrogen oxide emissions. So basically, kaninga koan, acid rain is caused by a chemical reaction which begins when compound like sulfur dioxide, and nitrogen oxides are released in the air. And then basically acid precipitation man, so kung ma-release siya sa air, it will be accumulated in the air as well and could also join when a precipitation happens or kung mag-ulan. So kana siya no nga mo react na din siya sa tubig, sa oxygen and other chemicals to form a more acidic pollutants which we call as or which we known as acid rain. Ang kaning mine acid drainage no is a result of mine water coming into contact with the sulfur bearing minerals. So it is formed no actually from pyrite, which is an iron sulfide. So it is exposed. When it is exposed and reacts with air and water, it forms sulfuric acid and dissolved iron. So katong acid runoff further dissolves heavy metals such as copper, lead, and mercury into the groundwater or surface water. So basically, kani acid mine drainage no, is one of the mining's most serious threats to water. So a mine draining acid can devastate river streams and aquatic life for hundreds and under the right conditions, thousands of years. So mao na siya. Na dili basta-basta ang acid mine drainage. So it may be kuan accumulated through time, then eventually naaapa lang gyapon siya, wala pa siya na rehabilitate. Maura gyapon siya, naapa gyapon siya content of or na pa siya level of acid rain. No, so that's it. So determining the pH of water. So we have the most accurate method of determining pH. We have the pH meter and the dye method. So an electrometric method wherein the H ion concentration is balanced against a standard hydrogen electrode. So kaning oyster series no as a lot of kining what they call this options on what to use, what specific analysis to use on the water quality. So na ay presence of pH po dara. Dayon na ako tong mga TDS, not TSS, TDS kato even salinity. No? Present, pwede siyang magamit aning nga kuan gadget or yes, apparatus. Dye method is A simple and easy but somewhat less accurate than the electrometric. So this method used certain indicators. So I think you already know this, you have already encountered this. This is a strip, pH strips in which kung hibalaan mo, you just dip it into the water and then see if sa iyang color. So you will be given a basis for a particular color, which corresponds to the pH volume of the water. So, kaning mga dye method na many dyes change color when pH is increased or decreased, making it possible within the range of the indicator to estimate the approximate H ion concentration to a solution. So, mo na siya no, change siya. So you can identify whether you have ang iyaha lang is whole number lang ang iyang mahatag nga result 1 to 14, but for the electromagnetic electrometric nga kuan method na you can know decimal points, you can have it with decimal points and your result you have 7.12, 7.5, and so on. So that's for determining the pH of water. So another one is the pesticides, no, organic pesticides. So the term pesticide is a composite term that includes all chemicals that are used to kill or control pests. So basically, kung may pesticides used to kill or control pests. So pesticides are used to protect crops against insects, weeds, fungi, and other pests. So they also play a significant role in food production. So kaning they protect or increase yields and number of crops which can be grown on the same land for number of times per year. So mo na nga mo po na siyang effect na ang pesticides, though it's not really easy to grow crops without pesticides, but when they use pesticides, no, they can they multiply the food production in a year. So dagan kayo ilang mabuhat with pesticides compared with wala sila ibutang, no? And then we also have gas chromatography is a method of determining of organochlorine pesticides and chlorinated phenoxy acid herbicides in water. So, mga na siya. So now let's move on to toxicity. Okay, we are talking with pesticides, man. So we should deal with toxicity. So toxicity for mammalian and non-mammalian toxicity usually expressed as LD50 or lethal dose, concentration of the pesticide which will kill half the test organisms over a specified test period. So the lower the LD or the lethal dose, the greater the toxicity. So kung for example, LD1 na siya, kapatay na yun na siya, no? Okay, grabe na siya ka-toxic. So values of 0 to 10 are extremely toxic. So when LD50, medyo slight lang siya toxic, but when it reaches 10, it becomes extremely toxic. So drinking water and food guidelines are determined using a risk-based assessment. So generally, risk is equal to exposure, which is the amount and or duration, and the toxicity times the toxicity. So kung ikaw na-expose ka for this concentrated volume, let's say 20 ml concentrated volume of LD10 na pesticide, and then for 1 hour na exposed ka na. So there is number of, I mean, a calculation for the risk on how this substances enters your body, you know, or how this substances affects your overall system. So toxic response can be acute or chronic. No? So acute siya when it could lead to death, and chronic siya if the effect does not cause death over the test period but which causes unobservable effects in the test organisms such as cancers and tumors, reproductive failure, growth inhibition, theta, teratogenic effects, and so many more. So, facts for pesticides, guys. No? I'm really sorry for my background. No, naiga kuan dari sa grass. So, forgive me. But I still have to discuss kay mawala tas ato ang momentum. So, for pesticides, no, facts for pesticides, oh my God, are potentially toxic to humans and can have both acute and chronic health effects, depending on the quantity and the ways in which a person is exposed. Some of the older, cheaper pesticides can remain in the soil and water for years, and they have been banned in developed countries for agricultural use, but are still used in many developing countries. So, kana siya no na uban ana nga mo stay lang siya longer even if wala na ka nagamit, no? So, pang long term siya. And there are more than 1,000 pesticides used around the world to ensure food is not damaged or destroyed by pests. So each pest or each pesticide has different properties and toxicological effects. And kuan kaning toxicological effects no are multiple pesticides no can be greater than the sum of their parts. So basically, naa siya'y effect yun, no? Taas yung toxicity towards humans and other animals as well. So, how this substances are being or unsa ang ilahang fate no inside the soil or under or on the surface soil itself. So, say movement ani nila. So, there is what we call mobility in soil. Now that all pesticides have unique mobility properties both vertically and horizontally through the soil structure. So, kaning mobility no galihok-lihok ang kuan kaning pesticide bisan asa siya maybe let's say 1 kilometer away from the pesticide kung asa siya gi-apply, muabot dito, tungod kay magkuan na siya, mo run off ba yan na siya, no, ang tubig. Then, solubility in water, no, many pesticides are soluble in water out of necessity so that they can be applied with water and be absorbed by target. The higher the solubility of the pesticide, the higher the risk of leaching. So, mo na siya no nga, ang pesticide supposedly should not be soluble in water. Kaya kung soluble siya, dali ra siya ma-mix sa water. So, tendency would be mas taas ang percentage niya nga mo-leach siya sa ilalim sa tubig and would also pollute deep wells, pumps, no, na ay kanang potable drinking source of water for the residents and other locals no, within the area. And then we also have the microbial activity in which pesticides in the soil are primarily broken down by microbial activity. The greater the microbial activity, the faster the degradation Loss of pesticide residues can also occur by evaporation and photodecomposition. So in microbiological activity, no nga, ang ilang buhaton is more on degradation. So taas ang dapat ang kuan microbial activity so that it would also it would also um, yes, it would also fast or it will also convert or degrade certain kining soil faster, no? So loss of pesticide residues can also occur by evaporation and photodecomposition. So other pesticides, like for example cyanide, yung mga pesticides, no, it is highly evaporative. So dali ra siya mag-evaporate, pero kung malanghap pud nimo siya, no, taas kay ang iyahapon effect sa imuha, taas kay siya og impact. So another is soil temperature, in which soil microbial activity and pesticide breakdown is largely linked to temperature, to soil temperature. So basically, if taas ang soil temperature, there might be a relationship with the microbial activity. So kung ang microbial activity is more on moist areas siya, then definitely if the soil temperature is high, then medyo taas pud ang ang tawag ani ang less pud ang moisture sa isa ka soil. So definitely na ay tendency nga ang pesticide will not break down because of the soil temperature. So kana dili siya yes. Application rate. The more pesticide that is applied, the longer significant concentrations remain. So, kung taas ang concentration nga imong i-apply, basically, lisod kaayo siya tangtangon o mag-retain na siya, remain na siya dito na area for long periods of time. So, might as well that you need to apply lesser concentrations so that it can just shoo away kaning mga pests, but kanang avoid polluting or distracting other ecosystem, no? So kana irrigation management, no, irrigation increases the chance that pesticides will migrate to groundwater and surface water. So kani siya, ang may tabuan ni is kung na irrigation system, usually ginakalutan mo gud nila sa ilalom no kay para or sa kilid ba kaya para mulalum siya tapos matubigan dayon siya and then mo flow din siya into different katong say agianan nila unsay giunsa nila pagkalot sa ilang agianan nga matubigan dayon ang ilang mga crops. But since irrigation management has also a little of a bad side because this pesticide containing mga pollutants will migrate to the groundwater and the surface water, which eventually pollutes it. So kana. So namang good time mga na-consider na to nga mga infiltration rate in which the soil promotes runoff that can carry pesticides with it. So ang iyaha is for irrigation, no, iyang gina-promote is the downward movement of water beyond the root zone of plants, which promotes leaching to substances, including pesticides, to groundwater. So this is of particular concern in areas where frequent irrigation is necessary because of coarse textured nga mga soils. So kung dagko siya, mas ang mga pores man good is kung tagdagko ang mga pore size sa iyahang soil, ang tendency niya is dali ira mo sunog ang tubig. Pero kung gagmay gani ang pore size sa isa ka soil, mas mo retain siya og water. That's why taas ang moisture niya kung compact kaayo siya. So kung gamay kay ang pore size sa iyahang soil. So kung coarse textured soil siya, then meaning dagko ang iyahang granule sa iyang soil. So tendency is dali ra siya mo absorb og water, then dali ra pud siya mahutan og water. So dili na kayo mo retain sa soil ang iyahang gisunog na tubig. So that's one possibility no nga kaning necessary gid ang irrigation labi na sa kanang type sa soil. So proper irrigation management is critical to minimize the risk of pesticides infiltrating groundwater. So basically, there are still no movements about how we address pesticides, especially no when this certain area is practicing irrigation management. So, kung mag-irrigate siya, basin musunod na yung untong pesticide sa ilalom and it will also pollute the nearby potable drinking water. So, basically, naaya pa siya effect to the humans. So now, let's move on to the soil quality. No? As per USDA, no, soil quality can be defined as the capacity of a specific kind of soil to function within its natural or managed ecosystem boundaries to sustain animal and plant productivity, maintain or enhance air and water quality, and support human health and habitats. So soil quality, is an effective tool for monitoring soil function. Assessing soil quality involves measuring physical, chemical, and biological soil properties and using these measured values to identify properties of the soil that may be inhibiting soil function or to monitor how changes in management are affecting soil functions. So basically, humans are dependent on soil, and to a certain extent, good soils are dependent upon man and the use he makes of them. Kay tungod kay wala ta kabalo kung sige nabuhat na to, no? That's why mag-alter ang soil quality. So no matter how advanced our civilization and technology are, man is still dependent on the topsoil because this is where we get our necessities such as food. So more of our crops and even food are basically from dependent on the soil quality itself. So let us have this factors affecting soil quality. So for inherent soil quality, this is a resulting from the natural and soil forming process. So basically with the factors affecting natural phenomena such as kaning mga living organisms nga na present dara, and even time as time pass by, kaning topography kung asa dapit ang location ana, kung na ba siya sa uptown, sa taas sa mountains, sa kung nga sa mountains or where sa lowland areas ba kaya, and even the climate nga experiencing a lot of differences such as climates in, let's say, outside Philippines, US, which experiencing summer, winter, spring, fall, no? Unlike here in the Philippines, we only experience wet and dry season. So basically, atong climate is much favorable than other climates. So for the parent material of the inherent soil quality, usually this is the starting point for most soil development. So kaning mga parent material can be from the mineral rock and or organic matter. So when parent rock material is exposed to the atmosphere, or when the organic matter or material minerals are deposited on Earth's surface, soil formation begins. So this is where soil quality comes from. So medyo kuan siya. Muna siya ang pinaka main source niya kung asa siya gagikan yun. So the interaction between the inherent soil quality to the dynamic soil quality depends on the changes on due to human use and management. So there is what we call soil amendment, in which kaning soil amendment is a material added to a soil to improve its physical properties. So for example, water retention, permeability, water infiltration, drainage, aeration, and even the structure. It depends on the soil quality. Kung say ginabutang dito. So for example, ang atuang ibutang dito is i-amend nato siya, i-mix nato ang soil into compost, mix nato ang soil with shredded tree bark, or even manure, isagol nimo siya sa soil. That is what we call soil amendments. So we also have tillage, Tillage is, of course, the preparation of land for growing crops. So for example, you need to kanang plow it, or kanabitang imo siyang tawag till. I-till nimo siya, ikalutan nimo siya para murag madungagan nag-aeration sa iyang soil, and that's how quality dayon, soil quality dayon adds its importance to the crops. So another is, of course, we have the land use type, in which basically the soil quality depends on the land use type. So if kaning siyang soil quality is history niya, like for example, we relate it to the cropping history and cropping rotation, in which that if this agricultural land area originally is residential siya, there might be a change in soil quality. Or for example, swamp area ni siya, then himuon nimo siya og kanang industry, or tukuran nimo siya building, and then eventually in the near future you'll convert it into agricultural land areas. So dili na siya same ang iyang soil quality. It's because lahi-lahi na ang iyahang history, iyahang history about that particular area, where mo siya i-convert into another land use type. So land use type specifically on functional zoning, for example, includes industrial, agricultural, and even residential nga areas. So kung magdepende na siya kung sa iyang effect sa crops or sa plants nga imuhang itanom dara nga area. So now let's have soil quality versus soil health. So what is the difference between the two, or how are they related? So basically, when we say soil quality, it is the condition of the soil to predict its productivity. So moingon ta nga ang quality sa soil is good if makita nato nga pwede siya, taas ang iyahang growth or taas ang iyahang productivity, daghan siya og ma-produce nga crop or even plants in that kind of soil quality. So this is the capacity of the soil to function within its ecosystem boundary to sustain biological productivity, maintain its environmental quality, and promote plant and animal health as well. Pag moingon tawag soil quality, no, soil scientists prefer soil quality in which that they described it as quantifiable physical, chemical, and biological characteristics. We cannot say the soil quality is good when we do not know what the physical, chemical, and biological aspects of this soil, no? So, meaning kailangan nato siya hibalaan para makaingon ta nga, uy, good quality day ang soil. Dapat ato siyang i-measure ang iyahang physical, chemical, and biological factors or characteristics. When we say soil health, though, on the other hand, soil condition, it is where in the soil condition to predict how soil function. So, unsa di ay ang iyahang buhaton, no? Ang soil health, unsa di iyang pwede nga mabuhat. So, it is defined as the continued capacity of soil function as a vital living system by recognizing that it contains biological elements that are key to ecosystem function within land use boundaries. So now I'll give you a figure in which we can further know the relationship between the soil quality, the soil health, and napatay idungag na word which is the soil fertility. So unsa gid ay ang relationship ani? Now, let's proceed to this. So basically, this is the relationship between the soil fertility, soil quality, and soil health. You can see na ang soil fertility also contains soil properties, no, in which you cannot say that a soil is fertile if you don't know its soil properties, the physical, the chemical, and the biological. No? For it to be called as agricultural productivity, no? Na para makaingon ka nga, kani nga agricultural, grabe ka ni siya ka-productive. No? Kung magbase lang ka sa soil fertility. Now, for soil quality, no, it involves biological productivity, environmental quality, plant and animal health. So basically, ang soil quality does not only focus on the soil properties itself, but it focus on the kuan siya kanibitang iyahang kadugayon ana nga area in terms of na ba yung mga kanibitang mga environmental quality kung butangan na nimo siya og pesticides or something na naanay introduce sa iyaha unsa pa ba yung quality kung ang soil quality po no determines in terms of the air quality and water quality. Like for example, if less lang ang tubig dara, unsa may quality na sa soil. So they are somehow related to the soil fertility kay soil quality cannot be called as good or cannot be cannot be considered as good if dili siya mabuhi or dili siya kinibitaw wala siya dili siya ma-sustain for a long period of time. So basically ang soil health is long term, no? You can see nga ang soil health and soil quality has the relationship in which nga ang soil quality is the bigger scope of soil quality. Ang soil health is a bigger scope of soil quality. Again, kay ang long term niya should be for the benefit of agriculture nga productivity. So kani siyang soil health should be based on the ecosystem services. Like for example, naa ba siya presence of minerals, naa ba siya like katong mga let's say kining magnesium, no? Naa ba yung mga presence ngayon ana. So kung wala siya yung mga presence ngayon ana, then maybe dili healthy ang soil. So ang quality niya bad. Kay eventually kung ang soil health dili na nato makita pa lang sa soil health no nga magdugay siya, how much more ang quality sa soil. So siguro kung dili walay present na minerals and other kuan kanang living organisms dara, meaning ang quality sa soil pangit kay siya, maybe dry kay siya, nagbitak-bitak na siya no, kanang bitang meron siya og na kaning nag-crack na siya no, muna na ang soil quality. So meaning dili pud nimo siya pwede maingon nga soil fertile siya kay kung nabitak-bitak siya unsaon nimo pagtanom di mamatay ra gyapon, so dili fertile ang soil. So this is the relationship between the soil health, the soil quality, and the soil fertility. So kanino, if we can base this na the soil quality is the capacity of a soil to function. So mo na siya, maybe in the farm or in the ecosystem, and thereby sustain productivity, maintain environmental quality, and promote plant and animal health. So basically, the soil quality and soil fertility is somehow the same. So ina na siya. So ang soil health dari is nara siya, union siya no, union. Kaniman siya union na kung walay chemical, physical, biological, meaning dili healthy ang soil. So ina na siya. The aim is to manage for balance between all three soil components. So kung maingon tag chemical ra tanan ang present ana, then maybe dili siya healthy na soil. Naalang siya, ang yung soil quality is taas siya in terms of chemical, pero yung soil health is very low. Kay you need the presence of three, the physical, chemical, and biological. So kung wala sila ana no, walay isa ang out ana, walay presence ang isa ana, then therefore there might be a unhealthy soil, na kay unhealthy soil. So mo na siya no, three broad categories, no, the physical factors, chemical factors, and biological factors. You can see nga, ang depth and water holding capacity are physical factors. For chemical factors is the nutrient availability. For the biological factors are microorganisms present, no, and their interaction among themselves. So basically, if you have the presence of the physical, chemical, and biological, then you have a healthy soil. But if you have only the presence of the chemical, then the soil quality is good chemically, or the soil quality is good physically, or the soil quality is good biologically. So then na siya manage. So you have to manage for balance between the three for you to conclude that the soil is healthy. So mauna siya. So now let's move on to the initial steps in assessing soil to identify the management goals. So for a soil managed for food production, functions such as providing a suitable plant substrate and serving as a nutrient reservoir are important. So example na food or fiber production or environmental protection, for example, nga determine mo ang soil function that contribute towards accomplishing them, na dapat ma-manage nimo ang food production na within that ana nga in an area dapat taas ang nutrient in order for it to produce a lot of variation or variance ng mga crop production. So another is a soil managed for environmental protection. These are the key functions. The key functions are storage and purification of water and interactions with the atmosphere. So basically, once soil function important to a management goal are identified, a soil properties influencing those functions can be selected for measurement. So example, ato ning matawag na function ay kaning tanawon nato kung unsa ang mga measurement for this type of function in this table. So it would also depend on the location and the soil type itself. No? Again, kani nga mga soil function, magdepende siya sa location, and of course the soil type, kung unsa nga type sa soil ang present in that area. So for example, if we consider substrate for plant growth, no, like book density, aggregate stability, and soil depth, dapat unsa nga mga properties ang imuhang i-consider within that kung kani ang imuhang i-assess sa imuhang soil. So if you are planning to study soil analysis, no, you can use this information na which I got from a journal nga na ay specific nga mga soil function nga imuhang gusto nga i-attain. So dapat in terms of physical, chemical, and biological properties, mauni ang imuhang i-assess. So sa imuhang method, pwede nimo ni siya mabutang. Na kung for example, you are aiming for, let's say, atmospheric interaction sa soil. So imuhang ikuan for physical properties, you have the water-filled pore space, imuhang i-assess kung unsa na siya. Then for the chemical properties, i-assess kung imong organic nitrogen content niya, tapos yung extractable P or phosphorus, dayon i-determine mo ang pH niya, iyang carbon dioxide flux, no, NOx flux, methane flux, and many more. So basically, no, kana ang unsaon nimo siya, no, kung unsaon nimo siya paggamit sa imuhang methodology, no, in your methods of research and by research. So however, there are signs that human activities threaten the quality of soils. So activities such as, let's say, continuous cultivation, use of chemical fertilizers, pesticides, and even acid rain have brought about negative impacts on soil. So basically, soil function does not only or does not solely kanibitang as is lang siya, pero you also have to consider a lot of factors po. Like for example, if you want to know the soil function in terms of biological activity, for example, so kailangan tanawon po nimo nga usay intervention of the humans nga gibuhat ani para ma-alter ang biological activity. So ayan din mo may balaan no kung say effect ani microbial biomass, soil respiration, potential mineralization, and earthworm population. So kana siya, you have to do that in your methods so that naamoy mabutang kung sa inyong kailangan mabutang dito used for your methodology. So, indicators of soil quality. So, you need to consider, no, basic yun siya nga, ang soil quality should involve the following. We have the soil pH, soil organic matter, soil moisture, soil salinity, and even the pollutants in soil. So, basically, for soil pH, no, you have two methods to determine soil pH. We have the electrometric method, which is the most accurate method of determining soil pH by means of pH meter. So, pH meter for the soil ni siya, na ito siyang pH meter sa water. Dili sila same. We also have the dye method, a very simple, easy method, but somewhat less accurate than electrometric method. So it changes colors with an increase or decrease of pH ranging from 3 to 8. So kaning lamot, no, is present na siya na siya sa ato ang NYSI department, but this is less accurate than the electrometric because it can only give qualitative result. When I say qualitative, descriptive ra siya. Mura siya o kinibitang acidic, basic, inana lang. Pero wala siya quantitative na result. Like the electrometric method na siya 24 point something, 21 point something numbers. So, kani qualitative lang siya, descriptive lang siya. So, present, absent, muragin ana lang ang iyang ginhatag nga result. So, Basically, no, kaning mga extremely useful indicator for the general physiological condition of the soil is, of course, ang three conditions lang yun sa soil is the acidity, the neutrality, and the alkalinity. So, muna siyang i-measure nato if we want to know, no, or determine the soil pH. So, another is the soil organic matter. So, as you can see, soil organic matter is the organic component of soil consisting of three primary parts, including small or fresh plant residues and small living soil organisms, decomposing, which are active, and the organic matter and stable organic matter, which is what we call the humus. So basically, we have the humus as the biggest, no, or as the major soil organic matter component based from the USDA and RCS. No nga, it consists about 33% to 50% of the soil. No, so muna siya present in the soil, followed, yes, together with the decomposing organic matter. So usually kanina no, they are in a way has the relationship kay kaning mga organic matter na decomposing organic matter comes from the animals, no, which are decaying and could also give um, nutrients to the soil, back to the soil. So that's what we call the kuan katong soil cycle, 'di ba? Soil cycle na siya. Nato. Katong nitrogen and even phosphorus cycle kana siya. So for soil organic matter, no, it is widely seen as a major factor in the decrease of soil fertility and crop yield after forests are converted to agricultural use. Syempre, kay, it's because isa po niya sa mga kaning important na indicator sa soil quality. Tungod kay kung for example, ang fertility sa soil nung gikan sa forest, let's say ang forest kay gisunog ninyo, kay converting nyo siya into agricultural land area or agricultural use, then definitely it would alter the or it will decrease the soil fertility of of the area. Ito nga kay gisunog naman siya, so ang katong mga living organisms inside the soil or under the soil will die, and kato sila ang isa sa mga factors nga nganong fertile ang soil. So eventually, no, mga matay to sila, pag sunugon ninyo ang forest, then it will no longer be useful for agricultural land use. So ina na siyang effect. So many agricultural practices such as continuous plowing, drainage, and limiting may increase the rate of mineralization and thus promote crop growth on the short but speed up soil depletion. So for mineralization, no, natay ka itong mga plowing nato na ginatawag na iplaw kay para na aeration yung hitabo sulod sa soil. But since the more we plow now, it would also increase the rate of mineralization na taas na ang minerals na makuha. And although it would greatly it will greatly affect the crop growth in a way nga tagaan niyo siya o mag-promote ang growth, but dali ra madaot ang soil. So, ma-deplete ra siya eventually. Ito mo, kinahurot naman ang minerals sa soil, i-take up naman siya sa crops. No? That's why nga naggo kay sila. So, muna siya no nga, we need sustainability of food crops production because it is also relevant to greenhouse gas emission, no? Nga i-relate na to siya sa soil biodiversity nga kung for example dili na to i-take care ato ang soil, no, ang may tabuan na is there might be changes in the environmental conditions such as kining and even the ecosystem condition nga kung wala nay kuan medyo init na kaayo, dili na kayo na naka-perform ang kuano ang cycle sa soil, minerals, and so on, it could greatly affect humans and even animals, no, who are also relying on this, on the productivity of the soil, no, kanang mga soil crops. So another is the soil moisture, no. It is the fundamental importance to plant organisms, and no environmental study would be complete without measuring this factor. So walay ko ano dili ni dapat gamiton niya po ninyo ni sa inyo ang if you want to deal with soil quality in the future sa inyong thesis kay soil moisture is very important po. So soil moisture is very dynamic. No one say dynamic. It is characterized by constant change. So iyang activity, ang iyang progress, no, it depends on the kanang soil moisture. So, for example, no, when precipitation reaches, no, for example, mag-ulan, when precipitation reaches the soil surface, then part of it runs off as the surface flow. Pwede siya musulod dito sa ilalom. Or maybe some evaporate into the atmosphere, so evaporate siya, while the remainder percolates into the soil to be stored in the interstices between the soil particles. So when nitrogen, no, kani siya, basically if you can still remember your biogeochemical cycle, no, kaning nitrogen inputs is coming from the lightning. So once the lightning hits the soil, it gives nutrients, no, and it will convert other organic matter sa soil and then convert katong total nitrogen from nitrogen, no, to nitrate to nitrite, then some ammonium nitrate, some ammonium ions, no, convert to nitrate kay tungod kay ang ammonium is kung large amounts lang siya present pero dali ra siya, it will eventually convert into nitrate. So mga ammonium ions. So that's how, no, how nitrogen percolates or runs off to the surface flow. So kung kato siya, no, when all of these spaces are filled with water, all the air sacs, no, kaning mga air sacs, anak ko to. Yes. When where am I? So when all of these spaces are filled with water, all air has been driven out and the soil is waterlogged. So definitely medyo moist na ang area, so mapuno na siya tubig, so magbasa na siya. So there is a high moisture, no, to that particular area, but dili siya filled with water. It's because there is the presence of trees now, which of course due to gravity would uptake water, no, yang i-uptake ang water ng gravity pulls down the water, and then adhesion in which na i-absorb ang tubig sa trees for it to use, no, for survival. So pero however, no, after a few days, no, provided with nothing is added, kung wala tayo gi-add dari sa tubig, sa soil, the excess water is drained away under gravity until the rate of drainage is slight or zero. So basically, the soil moisture, no, degrades if wala na presence of water nga mo sulod, or kung wala na siya presence of converting organic matter into other forms such as nitrate, nitrite, ammonium ions. So ang mahitabuan ni is ma-degrade na ang iyahang soil properties. So it will lessen the soil moisture and it would possibly no or eventually less ng moisture ani so dili na kayo siya makabuhi og other plant nga mga plant organisms. So wala siya nga ma-alter na dahil ng iyahang quality. So there are two methods of determining soil moisture. We have the gravimetric method. So the oldest and most used and perhaps the most reliable method of estimating soil moisture. So when this is the kuano kanibitang somehow very tiring method for gravimetric method, no, very tiring kay you have to do constant weighing, so it does not turn into constant. You have to do it every hour, every day, every hour of every day to, of course, attain constant measurement. So may balaan na ninyo in your, maybe in your water pollution, or if you have no kana siya water pollution. So for this method sa iyong soil, the soil water pollution and I don't know if you still have your kining monitoring, kay you will be doing this in your lab sa monitoring. So I hope na makatuon mo gravimetric method, kay this is fun but tiring as well. So that's it. So this volume is then heated until all moisture has been evaporated and the dry weight is obtained. So ang iyang kuan ani no yung iyang process ani is imuha siyang i-weigh ang soil. Tapos imo din siyang i-oven dry, mag-dry weight ka. So dry iyang imuha sang kuan no, i-measure sa nimo tong nakuha nimo nga soil originally, yung initial, that's what we call initial. Then you have to put it, maybe you dry, kuan siya, either oven dry or natural dry lang sa kuan, air dry. So tanaw na nimo ang iyahang weight after drying. So and you need to do constant weighing. So undergo nimo siya og oven drying hangtod sa kuan ka sa iyahang constant weight, which is the initial. You have to base the initial weight of the soil. So another method we have is the neutron scattering. So this method uses radioactive material to measure soil moisture, but we don't have that here in USTP. So the principle is that neutrons given off by a radioactive source slow down according to the concentration of hydrogen atoms in the soil. So kanina basically these hydrogen atoms now occur mostly in water, so that the number of slow neutrons reaching a detector is correlated with the amount of water in the soil. So basically, this kind of method is directly, what do you call this? Directly related to the water, containing water in the soil, amount of water in the soil para magamit ang neutron scattering. But if there is no presence of water, kay tungod kay grabe siya ka-dry, you can use other method. You can use gravimetric method. So gravimetric method and neutron scattering, no, you can refer this in the uploaded video I posted in your use tab. So it will be your guide kung say way niya. So kana siya. So let's now move on to salinity. We have few slides left, no? Salinity refers to the accumulation of soluble salts of sodium, calcium, magnesium, and potassium in soil. Salinization may also result from intrusion of salt water from the sea when there is excessive withdrawal of fresh groundwater. So salinity reduces the quality of soil and its productivity. So basically, kaning salinity can be measured if, for example, um, naay kaning, asa ni kaning presence of sodium, calcium, magnesium, and potassium in the soil. Medyo na naturally naay inani sa soil, but not in large amounts. Kaya if large amounts na siya, this would also deplete the quality of the soil and dili na siya habitable for other crops or other plants, no? So ang mahitabo ani is that kaning mga salinity is kaning salinity is measured uh, through an ions in which that they can be mostly found in chloride and sulfate and with some carbonates and bicarbonate, no? So basically, kung ang mga salts, they have been carried upward by capillarity and have remained when water is evaporated. So this can be measured by total concentration of salts expressed in moles or by using electrical conductivity meter. We have an electrical conductivity meter in water, but in soil, so far, I haven't encountered salinity meter for soil, but we'll ask Sir Ket if naa kay I've been imagining na kaning salinity can be measured kung ang soil basaon nimo siya og tubig dayon kato dayon i-measure din nimo ang tubig sa iyang salinity. So I don't know if that's possible. So kana siya. That's in my mind for measuring salinity of soil. So kaning salinity is present man gud ni siya if the area is also has a nearby kinibitang body of water nga na intrusion of salt. Especially kung infiltrate ni siya sa soil, no? Dayon, musagol siya sa soil. Or maybe, kaning salinity is source po ni siya sa mga pollution in which nga polluted ang area and then naay salinity nga presence. There would be the presence of salinity in the area kung naay presence of kining sagbot. So that's it. No? Another is the pollutants in soil. Of course, soils can retain, modify, decompose, or absorb pollutants. But due to the effect of kaning throwing garbages everywhere by not segregating it, and even kining nasunog na, there is kanabitang evident na nagsunog gikan nagsunog nagnakuan. So naa na siya effect, great effect to the soil. So maybe this soil quality here would not go back to the original soil they have kay nanay presence of gasoline, nasunog pa gyud siya, so nanay depletion. Even the microorganisms no on that particular area no cannot survive as well. So mo na siya no. Kani mga biodegradable organic materials deposited into soils are decomposed largely into such safe products as carbon dioxide, methane, nitrogen, and phosphorus compounds. So eventually kanang mga let's say kanang bitang mga landfills or even kani mga kating zayas bitaw nga they call it landfill but actually it's an open dam site. So it's not called as landfill. Katong bago nga landfill karon nga naa na dapit sa Pagalungan. Yes, I think that's it. Muna to siya ang landfill. It's a combination of kanabitang tabunan mo siya. Ang landfill is kuan siya, yuta siya, basura, then tabulan na pudog yuta, basura, inana. But in Zaya's open dam side, no, ang ginahitabo is tambakan lang siya basura, so wala na siya itabon-tabon. Then sagol pa gid siya. So mao na siya, no. Na siya great effect. Now, kung for example kato, it needs a lot of rehabilitation to make for the Sayas landfill to convert it into another land area. Like for example, i-agricultural nimo siya. Kaya I have this thesis mga advices na po nga studying the soil quality in Zaya's landfill after closure. They still found a large amounts of pollutants in the soil. And the only way, tas ilaha pag yung ginaplano daw adto kay they will convert it into agricultural land area as well as kining eco park. So I don't know if it will be possible, maybe in time, but for now, it needs a lot of rehabilitation to make for the Sayas open dam site, no, to become or for its soil to become healthy again. So kana siya. So these are some of the effects na we usually do sa auto ang mga soil sa itong crops, no? So today, large amounts of commercial chemical fertilizers are applied to agricultural and grassy urban land areas, no, elsewhere in the world. And to control pests and weeds, farmers and urban dwellers have been using chemical pesticides in amounts that is environmentally damaging. So if we can stick to organic farming and organic fertilizer, using organic fertilizers, then maybe we could apply this. But since organic fertilizers manggod kay would take trial and error, and then some of the effects of organic fertilizers is less ang productivity niya, so gamay ra kayo ang matreat nato. And ang productivity man good, we are relying to the productivity of the crops kay the demand is taas yun ang demand. So if we use organic farming, organic pesticides, so there will be a possibility nga gamay ra ang ma-yield nato kay i-concentrate raman nato ana nga area. But in terms of inani mga synthetic, paspas kaayo ang atong mahatag nga remedy. So paspas pod ang yield o paspas pod ang productivity. So ma-sustain nato ang demand sa ato ang current situation. So that's it, no? And then the methods for determining organic pollutants in soil involve extraction of soils, followed by the measurement of pollutants by gas chromatography. So in anyang iyahang buhaton, no, naka-inject in sample, and then it will process to the column, and then the detector says that in aniyang analysis na ay presence of heavy metal, na ay presence of calcium, magnesium sa padiha. So that's how gas chromatography. So I think I've already posted how gas chromatography, is done, and you can watch the video I have uploaded in your step. So please be guided. So I think that ends our topic for week 4 to 6. So I hope that this coming Thursday you'll ask questions that are not clarified, that are not well explained by me. I will appreciate that. So maybe some of the kuan kining to call this minute nga mga informations kay nakuha na ko na wala na ko na studya og maayo, so you can just ask questions on Thursday. So please be reminded that October 5 will be your um, prelim exam. So please prepare for study week 1 to 6 and internalize everything. Do not memorize. Analyze, internalize, you comprehend. So that's how methods of research, no, is done in this topic. So I think that ends our topic for today. So I hope that some of your um, some of the topics were clear, or some of the topics are well explained by me. So if you have any questions, you can just ask me on our consultation this coming Thursday. So that's it. So have a blessed day ahead and keep safe, everyone. God bless.